Good morning, boys and girls. This is Mr. Giamini. For my EDM kids, it's a little help with special cases. Now, I have three special cases right here. I have the first one is 3 times 4 is equal to 4 plus 4 plus 4. I have 15 divided by 15 is equal to 1. And I have 6 to the first power is equal to 6. Now, what we're going to do today in class, and we talked about a little bit yesterday in class, is transferring a special case and making it into a general pattern, which we also really call an algebraic expression. That's kind of or use that as a 7th grade term here. So the general pattern, which is really just an algebraic expression. So when I say general pattern, I am meaning algebraic expression. If I say algebraic expression, I'm meaning general pattern. So if I look back at my first example, 3 times 4, the little dot there stands for times. We want to get away from using the multiplication sign that we're typically used to as x. We'll start using the little dot there, or we can use the asterisk. So 3 times 4 is equal to 4 plus 4 plus 4. Now I'm going to look at both sides. The thing that's the same on both sides is that 4. So I'm going to replace that 4 in my general pattern algebraic expression with a variable. Now what's going to stay is that number 3, that digit 3. So I become 3, now it becomes 3, and I'm going to put 3n. Now notice there's no operation sign in between the 3 and the n. All that means is I'm taking the variable n and putting it together 3 times, or multiplying 3 times the variable n. Now that is the same as n plus n plus n. So I can plug any number in here. Let's try 5. I think we all know that 3 times 5 is equal to 15. Now, because I know that n is equal to 5 now, I go over here and I plug in 5 here. 5 plus 5 plus 5. 5 plus 5 is 10, plus 5 is 15. So that becomes my algebraic expression for this special case. If I take a look at the next one, I have 15 divided by 15 equals 1. Now, the number that's repeated in this problem, in this special case, is the 15. So I'm going to replace that with a variable. But whatever variable I use, something divided by something must always equal 1. So notice 15 and 15 always be the same, so I can't say n divided by t. The variables are different. I need to use the same variable to represent the 15s. So when I go to write that algebraically, or using my algebraic expression, just say, and I'll use a different variable here. Let's go s divided by s is equal to 1. So I can plug in any number, any value for this variable of s, and since they're both s's, the value will be the same for both the numerator and denominator. It'll always equal 1. So if I plugged in 10 here, if s was equal to 10, 10 divided by 10 equals 1. I can plug in 100. 100 divided by 100 equals 1. So again, going back to my special case, they started me off with 15 divided by 15 equals 1. I now need to change that into something algebraic, and I'm saying to myself the 15s are the same. So that's going to be my variable. And I'll say 15 divided by 15 equals 1. Okay, 15s are the same. 1's the difference, so that's going to stay the same. And I'll just say, hey, I'm going to take out the 15 and I'll make it the variable of s. S divided by s equals 1, where I can plug in any value for s, and it'll always equal 1. And then finally I have this next one. 6 to the first power equals 6. So anything to the first power will always equal that other number. So I see that the things that are the same here are the digit 6. The only thing that's different is that exponent of 1. So I'm going to keep the exponent of 1, but I'm going to replace the 6 with a variable. And since I've already used an n and an s, I will use the letter b. So going back to my special case, it was 6 to the first equals 6. Well, I'm going to replace the 6 and use it with a b. So now I have b. Now the thing that was different in there was the exponent 1. So b to the first, that'll stay the same, equals b. So again, plugging in any value I'd like for b. It could be 10, it could be 20, it could be 30. 30 to the first will always equal 30. 10 to the first will always equal 10. So again, the b's must be equal to each other. I want, again, this equal sign means that both sides of this algebraic expression must be equal to each other. I can't have one side being 5 and the other side being 8. Those aren't equal. Hopefully this helps you a little bit more with special cases and algebraic expressions. Have a great day.